Hi guys, today we're going to do another classic game called Tic Tac Toe, or also known as Noughts and Crosses and O's and X's, I believe. So let's start off by opening Eclipse and creating a new package. Yeah, you can create a new project if you want to. Just create new package. Tic Tac Toe. We'll then create a new class by right-clicking on the package and selecting class. Then name it TicTacToe app. We'd like to have the main entry point, and we're also extending a JavaFX application class. So we'll need to import that as well. Once we've done that, we need to implement start method, or rather override it from the application class. And we can start. So in the main, we'll simply call launch. And the very first thing we're going to do is display the application. Stage show primary stage set scene, new scene with our custom content, which will be in the private method, which returns a parent. As always, we'll define a pane with set preferred size. Let's do 600 by 600. A square and then return root. Import everything, and now we've got a window, so an application with 600 width and 600 height. Now in TicTacToe we have what, tiles? Yeah, 3 by 3 grid, and each of the squares of the grid is technically a tile. It might have another name, but tile will do. Tile extends stack pane, because we'll have things like borders, and then we'll wrap some text objects. So public tile. We don't really need to pass in anything, I don't think. So we'll just create a border first. New rectangle. Since it is a 3 by 3 grid and we have 600 in width and height, we might as well do 200 by 200, which gives us a sort of perfect 3 by 3 square that fits on the screen. Border. By default it has fill color black, so we need to replace that by null, which will make it completely transparent. And then we need to specify stroke color, which is the color of the border. Oops, color black. Make sure we are importing JavaFX packages and not Java AWT. Right, we then need to set alignment of the objects or UI elements within the stack pane to position center. And finally, we'll add our objects to a list of objects of the stack pane. So we only have border at the moment. Yep, that should do it. So we have a 3 by 3 grid, so int I 0, 3. We create a new tile. We then set translate x of the tile to, so j is our x value, so j multiplied by 200, and I is going to be our y value, multiplied by 200. Get children, add tile. So we've created our tile, and then we add our tile to the list of children of the root so that it could be displayed within the scene graph in JavaFX. So now we have an application with grid. It doesn't do anything at the moment because we haven't really done anything. Now we need to be able to draw x and y, or x and o rather. This could be done by onClick event. That should do it. So if we define a text first. So when the application starts, when we create our tile, by default it will have empty text. And we'll be able to draw things by just calling drawX, which will set text to x. Actually, that's it. There's nothing else we could do. Draw O, which does similar that. Okay, so now this should be done on click. So set on mouse clicked. Then do this, and if it's a, so we can call this method because we're extending stack pane, so we're inheriting all the methods from that. Stack pane deep down is a node, JavaFX node, as you can see. So we hence inherit all of these methods from the node class, and we can call them, which is great because we can, there's no need to do manual checking with x and y. Instead of getting like x and y position of the cursor, then trying to find out where it lies, within which tile it is, we simply set on mouse clicked. So we set a callback on the node itself. So it is very object oriented. Event. So basically this code will be executed when the mouse is clicked on this tile, on this particular tile. So we'll do, if it's a left click, because it's mouse event, we can query it to know which button was pressed. Mouse button. Primary is the left and secondary is the right. Most of the time anyway. So if it's a primary key, then we draw X. Secondary, draw O. Alright, let's test it. So that was the left. Okay, that didn't work. So mouse clicked. I am clicking. Oh, we haven't added the text to the list of children. That's why. So left click displays X, although very tiny X. We need to increase the font of our text object. Font 72 should do, I think. Yeah, so at least it's visible. So right click gives us O, left click gives us X. However, it is against the rules of the game to be able to draw only one type sort of 2 times in a row. So we want to have a flag. Boolean turn X. So when we start, the player with the X starts, and then they'll take turns to do the drawing, which means that primary, if not turn X, then return. So sort of defensive programming style. So if it's not X's turn, then we don't do anything. In this case, it's the opposite. So if it's turn for X, then we return. So if it's left click, we also need to actually change the value as well. So draw X, now it's not turn for X. Draw O, and now it is turn for X. So we set to true. That's a left click, no doesn't do anything, and right click does. Another right click doesn't work, and left click works. So we now have our basic logic. What else? So we need to be able to determine the winner and whether the game is playable or not. So it means we need to have another flag called playable. When we start, the flag is true. So if it's playable, then we can click our tile or tiles. So if it's not playable, just return, because there's nothing else we can do. Alright, that looks okay. Draw X, draw O. We also need to check the state of the game, so we can decide whether it's playable or not. Void check state. So after we draw X or draw Y, we just check the state of the game. Now in this check state, we need to check what, 3 horizontal positions, 3 vertical positions, and then diagonals. So we'll need to probably create another data structure. Yeah, if we call it combo, and this data structure will hold 3 tiles, so an array of tiles. And in the constructor, we'll take tiles. So I'll just assign tiles to the array. And we also need to be able to check whether this combo is complete. So public boolean is complete. We'll need to check the 3 values of each of the tiles within this array, which means that we need to be able to retrieve those values. So in the tile class, we'll need to define a getValue method. String getValue. We'll simply return the value of the text, get text. So there are essentially 3 values, 3 possible values for that text. By default it's empty, so when we start the game each tile is empty. When we draw X, the value becomes X, and when we draw O, it becomes O. So if it's empty, it is not complete. So if tiles 0 is empty, actually it's getValue. Value is empty, then we return false. Else we'll need to check that value against 2 other tiles. So return tile 0 value equals tiles 1 get value, and tiles 0 value also equals tiles 2 get value. So when we create our combo object, we will pass in 3 tiles because one combo consists of 3 tiles. So whether it's horizontal, vertical, or diagonal. Is complete will decide whether this is the winning row or column. So we will start off with the checking of the first tile in this array. If its value is empty, then this tile hasn't been clicked yet, so there is no point in checking other things. So it simply return false, saying it is not complete. If it doesn't return empty, then we check this value against tile 1 and the same value against tile 2. The values are not empty because we do this check first, which means that if this equals that and this equals that as well, they have the same value, whether it's X or O. And in this check state, we'll go through all the possible combos and then check all of them, which means that we need to have a list of combos. List combo. Which we will populate in a minute. So we'll go through all of them. For each combo within the list, combos, if combo is complete, then playable is false because the game is no longer playable. Someone has won, and we break out of the loop, so there's no need to do other checks. We already call check state here. Yeah, that's right. Now we need to populate our combo, which we can do by, so we need to get that. Alright, so we can do a 2x2, not 3x3 grid, so essentially a 2-dimensional array of tiles, which we'll call board. We can hard code those values because we know definitely that it is a 3x3 grid. So we've created our array. Now we need to populate the array by assigning values. So board J is for X, so J comes first, then I, and is tile. So we assign tile to each of the elements in the array. So Ji, essentially it is X, Y. Now that we've done this, we can now go through the list, whether add to the list of combos. So first we'll add the vertical. So Y changes from 0 to 3, but X doesn't change. So the X is going to be 0, 1, 2. Then we change Y. Oh, it's actually horizontal, I think. Yeah, let's just see that. So combos, add new combo. And we need to include 3 tiles. The tiles will go from board, so we do not change the first value, and we put Y for the next value for the index. So that retrieves 0, 0, then 1, 0, then 2, 0. So it is, so if I open the application, so this will go through 0, 0, because y is initially 0, so it will start from here. Then 1, 0, so 1 in the x direction, y is still 0, and then 2, and y is still 0. Then when the y is incremented by 1, we go here. So it's 0, 1, 1, 1, and 2, 1. And finally 0, 2, 1, 2, 2, 2. So these are horizontal lines. Yeah, it actually helps to comment these things, because if you come back to the source code in a while, then you won't be able to remember what you want to do. Now it's for x, we'll just replace that by x and then y by 0, 1, and 2 respectively. So that gives us the vertical lines and the diagonal lines, diagonals, which are which are 0, 0, 1, 1, and then 2, 2. So it's 0, 0, 1, 1, 2, 2. That's this diagonal. Then there's that one, which is 2, 0, 1, 1, 0, 2. So the middle stays the same. The other ones, we just take the opposite. It's 2, 0, and 0, 2. So that should give us all the possible winning combinations, I think. So yeah, we covered this, we covered that, and then we covered the two diagonals. I think that's all of them. Right, so have we done everything? I think so. So now let's do the checking. So it's left, right, and then left. So this should have won by now. And yeah, it doesn't let me click anymore. So the game has now stopped, as in someone has won. Now let's do diagonal. Now left click starts first. So left, right, left, right, left, right. So this also works. Okay, now we need to somehow show which player won, which and then yeah, so by this point we know which combination has won, which means that here we can call something like play end of game or play win animation. Oh yeah, actually when when someone has won the game, they usually do the sort of line crossing through all of those values that they've used to win the game. This could be a nice thing to do. So play win animation, and we pass the combo. Yeah. Play win animation, which takes combo, which is the winning combination. And we need to create an animation which goes from one point and through the second point to the last one. Okay. Yeah, so it is essentially a line, so we can do a line. Import JavaFX line set start x. We will take the first tile from the combo. So combo tiles 0th element, so the very first element. and we will need to get its center X so that it's drawn from the center rather than from top left corner, which means we'll need to define a few more methods in the tile class. Public double get center X, which is essentially get translate X plus the half of the width, which is 200 divided by 2, we get 100. And because it's a square, the center Y will be the same thing, except we're using get translate Y. Right, so line set start X, center X, start Y get center Y, and exactly the same for the end coordinates, so that initially this will be displayed as a point, because if you create a line with start and end coordinates being the same, you're essentially drawing a point. So now we need to have a timeline, which is going to be our animation, because it's not really translation, it's more of a, so it's kind of a translation of the end, so timeline fits the best. New timeline. We'll need to animate key values, so we'll need to add a frame. Timeline get, we could get frames or something. Get keyframes, okay. Add new keyframe, which I think takes a key value. So we need to import all of those. As for key value, it is a property and then an actual value that we're going to go towards. The property that we're animating is line end and X property, and we're animating this to value combo tiles, get the last tile, which is 2, because we have 3 tiles for each combo, and the array indices start from 0, so we get 0, 1, and 2, 2 being the last. Get center X. Oh yeah, we also need to pass the time, the duration, actually. Duration of seconds, 2 seconds should do. So that's for X property, then we also have and Y property that we need to change, or rather animate. So we've created one key value, now we need to create another one, which takes line and Y property, combo tiles to get center Y. Now that we've created our timeline, we can now play the timeline, which is essentially an animation. Alright, let's try that. So XO, XO, X. Check state, label false, play when animation. Oh yeah, right, again, same state added in the beginning. We haven't added a line to the list of children of the root, so that we could that line could be displayed. Let's take this outside, and we can now call. So we'll create our line, and we'll need to add this to the list of children line. So it is now on the screen. Okay, X, O, X, O, X. Yep, very nice. We now have an animation of line going through all of these values that we used to win sort of the winning combination values, which is, I think, what we really do when we play classic paper-based X and O's, or whatever it's called, noughts and crosses. And let's do one for O. So X, O, X, O. Yeah, you might want to sort of speed it up a little bit, so duration of 1 second. X, O, X, X. So yeah, it's slightly faster. That looks better. Alright, so in just about 172 lines of code, we now have classic paper and pencil game called TicTacToe. You can subscribe if you want to see similar classic or more complex JavaFX games in the future, and thanks for watching.